Hello GCC, this is our third video in Chapter 6 for Chem 107. We are now going to talk about acid rain. Also, I realize there's a watermark on these videos because I'm using a free version of software. So do the best you can. You have the PowerPoints in... you have the PowerPoints in your Canvas folder. So in the announcement, so you can always look at those. All right, so acid rain. The pH of normal rain is 5.3, slightly acidic due to the carbon dioxide mixing with the water vapor and producing carbonic acid. So here we go again. Third time you've seen this reaction. You should know this reaction. CO2 gas plus H2O liquid. This time we're talking about clouds, the liquid, the water vapor in the clouds, makes H2CO3. So again, CO2 plus water makes carbonic acid, H2CO3. You need to know this reaction. So normal rain is around 5.3, but because of the excess CO2 we're putting in the air and other gases that we're putting in the air, we're now seeing pHs below 5, like 4.7, 4.8. That's called acidic rain. Rain samples have been collected since 1970 all across the United States and Canada. So you need to remember normal rain is 5.3, less than that is acid rain. Why is the rain becoming more acidic? Well, when we burn fossil fuels, we learned about those, right? Coal, oil, and natural gas. We create carbon dioxide, SOx, and NOx gases, which react with water vapor. So SO2 in water makes sulfurous acid. SO3 in water makes sulfuric acid. And then NO2 in water makes nitrous and nitric acids. That's a lot of acids up in the sky. So SO2, SO3, and NO2, SOx and NOx, and CO2. All of those up in the sky combine with water and clouds and make these acids that then rain down on us. Now you should remember SOx with an X is short for SO2 and SO3, while NOx with an X is short for NO and NO2. All four gases are main pollutants. We learned about them in Chapter 1. Okay, so all four of those gases, SOx and NOx, are primary main pollutants. This is just a picture showing acid rain. We have the smoke coming up in the picture. That's the acidic gases, the SOx and the NOx, being released from the coal power plant into the air. These gases are carried by the wind into clouds, where they combine with the water vapor in the clouds and make acids that literally rain back down on us. The acid rain kills plant life, it pollutes rivers and streams, it erodes stonework and marble, kills forests, it does all sorts of damage. So we don't need our rain to be acidic. This is a problem. This is an acid rain map showing where acidic rain is. The green is pretty much normal rain. We notice that's in the western part of the states. But as we move more east and especially north, we get more and more acidic with our rain. So acid rain is really a problem in the northeast. You should remember that. Acid rain is a problem in the northeast. Let's talk a little bit more about our SOx and NOx. SO2, the name is sulfur dioxide. You should know that. Sulfur dioxide is naturally produced by volcanoes. It's also produced by oil and coal combustion. One coal plant can make 40,000 tons in a year. Boy, that's a lot. If you look at the little molecule in the corner, you can see it has a bent shape. It's not linear, it's not straight, it's bent. SO2 is important in wine making. It serves as an antibiotic and antioxidant, protecting wine from spoiling by bacteria and oxidation. Due largely to the EPA's acid rain program, which you're researching, The United States has witnessed a 35% decrease in emissions between 1983 and 2002. That's pretty good. Inhaling sulfur dioxide is bad. It increases respiratory problems and disease, makes it difficult to breathe, and can cause premature death. So we don't want to breathe a lot of SO2. All right, so you should remember SO2 is sulfur dioxide, and it causes respiratory problems. A little more on SO2. 76% of SO2 emissions in the U.S. come from burning coal. 4% come from transportation, so cars, not a big contributor. 7% comes from smelting. What is that? That's when you heat a metal ore like copper or nickel to a high temperature to purify it, and then it releases some extra atoms in the copper ore like SO2. Canada claims half their acid rain in the east comes from the United States. Eek, we do estimate that about 4 million metric tons of SO2 do drift northward to Canada. Wow, shame on us. Next up is SO3. Remember the name, sulfur trioxide. SO3 as a gas is a significant pollutant. What happens is you can take 2 SO2s plus oxygen gas and make 2 SO3s. It is the primary agent in acid rain, so it's probably the worst one, the biggest contributor to acid rain. That's because it makes sulfuric acid, which you may have heard of before, and that's a very strong acid. Look at the little molecule in the corner. The shape is trigonal planar. It is prepared industrially on a massive scale as a precursor to sulfuric acid. In factories, SO3 gas is mixed into the flue gas, the exhaust, from the combustion to make the ash charge before flowing through some filters. The filters will then trap the ash, making cleaner emissions possible. So if we put the electrostatic filters on top of coal power plants, we can filter out the SO3 gas. That's kind of what they call clean coal. It's when they have these filters up there. There's nothing different about the coal. The coal is not clean. Terrible name. It just means the coal power plant has some filters up there. Honestly, all our coal power plants should have electrostatic filters to pull out the SO3. They all should. NO, nitrogen monoxide. Remember the name, NO, nitrogen monoxide. It's also called nitric oxide, but we're going to call it nitrogen monoxide. I think that's easiest to remember. The shape is linear. Look at the little picture. It's just 2 atoms. You connect 2 atoms by a straight line. Linear. NO is also an air pollutant. It's produced by cigarette smoke, car engines, and again the coal and oil and natural gas power plants. The use of the internal combustion engine has increased the presence of nitric oxide in the environment. One purpose of a catalytic converter is to minimize the nitrogen monoxide emissions by converting it back to oxygen and nitrogen element gases. So nitrogen monoxide in the air can convert to nitric acid, which causes acid rain. Don't confuse N2O, nitrous oxide, a greenhouse gas, and laughing gas with this. Okay, different chemical. N2O, greenhouse gas, NO, nitrogen monoxide, causes acid rain. Major pollutant. So NO is part of NOx, nitrogen monoxide, a major pollutant. And the last one, NO2, nitrogen dioxide. NO2 is also a major pollutant gas, just like all the others. SO2, SO3, NO, and NO2. All 4 of these are major pollutant gases that can contribute to acid rain. NO2, the little molecule in the corner we can see, is not linear, but bent. It has a bent shape. This is the gas that's reddish brown. If you look over into LA when you're driving up there, the brownish color is the NO2 in the air. You might want to remember that. NO2 is the reddish brownish toxic gas in pollution. So it can be prepared in air. We can take a couple of NOs plus oxygen and make a couple of NO2s. The main sources of NO2 are cars, the internal combustion engine, and power plants, coal power plants. Nitrogen oxide is also produced by nuclear tests and is responsible for the reddish color of the mushroom cloud from those nuclear tests. All right, and we're going to cut this video here. I think that's long enough. We have one more video to wrap up this chapter, Chem 107. See you later.